Okay, hi everyone. So this is another data analysis video, and again I'm focusing on tidying up and wrangling your data to get it into some sort of tidy condition where you can run some sort of statistical analysis or fit a model to it. Okay, so this follows on from the previous video. More data wrangling 6 was the previous video, and in that video um, we used the fear of crime data set, and I showed a way to extract values, to extract all the observations, participants from it that didn't have missing data. So it was a way of filtering it by extracting only those participants whose data wasn't missing. I thought what I'd do is demonstrate an alternative way to deal with and handle missing values in this particular video. And again, using that fear of crime data set. So what I'm going to do is show you how it weighs it rather than extracting values that we want to keep, saving them to another object. What I'm going to do in this occasion is actually drop rows that have missing observations, missing values. And also at the end, I'll show you a way that we could, if we wanted to drop variables that had a certain percentage of missing values, if it was particularly high or something like that, I'll show a way that we can do that quite easily and conveniently. Okay, so I'm going to start by importing pandas as PD and importing numpy as MP. And I'm going to read in the fear of crime.csv dataset here, and I've saved it as this object crime. So the data frame, I've named it crime, and I've used the pd.read_csv method. And it's the same one we've seen a couple of times in these videos now. We've got 5 variables: sex, anxiety level, stress, total worry, and constructive thinking. So I've kind of focused on this a few times now because for some reason, if I run this next cell, when I import this particular data frame, it's whereas often pandas will recognize the correct data type, in this case it saves them all as objects, as string variables, when they're all kind of numeric, really. All that sex and anxiety level are numeric values representing categories. That's not too much of an issue for what I'm going to do now, but the others are all scale variables, decimal values, but they've been saved as objects as well, so they're saved as like text strings essentially. So I'm not going to spend too much time explaining this because I've done it a couple of times now. I'm going to use the dot apply and the PD to numeric method, and I'm going to basically convert all those to numeric data types. So if I run, what I've done as well here is I've saved it as a new object. So I've taken the crime data frame that we imported, and I've saved it now as crime2. So if I run dtypes on crime2, you can see now they've all been converted to floating point numbers, which are decimal representations of numbers. Okay, and if you remember in the previous video as well, when we looked at the unique values for sex and anxiety level, which happen to be the categorical values, you remember it kind of sex, there should be 2 levels, so male and female, but it gave us this additional group, which was just like this empty string essentially. And the same for anxiety level, there should be levels 1, 2, 3 for low, medium, high, but it gave us an extra category, an extra group, which was also an empty string. And where I've converted these to numeric now, if I run that again for both of those variables, you can see we've still got this extra category that we don't want, but where they're now numeric values, you see they're 2 point, 1 point, so they're decimal representations. But the additional categories, which really were missing values, and when they were objects were represented as empty strings, are now represented as NaN, not a number. Okay, so essentially they are missing values, and the convenient when they were saved as strings, it wasn't possible for us to immediately tell that we had any missing values, but we can now see that they are missing values, or there are missing values, and those are represented by this NaN sort of category there. If I run this next cell, I can use the isNA method and combine that with the sum method to get counts of how many missing data points we have per variable. Okay, so if I run that for this crime2 data set, you can see we've got 1 missing value for sex, 7 for anxiety level, 1 for stress, 7 for the worry scale, and 13 for constructive thinking. So we've got a few missing values. Previously, when we kind of used the .info on the original data frame object, it kind of looked like we didn't have any missing values, but it shows you the need to care about your data and sort of investigate and explore it properly before you run any analysis. Otherwise, this will kick up all sorts of errors when we try to do certain things with it. Okay, so another thing we can do, we've got these counts, how many missing values we have for each variable, but we can also work out the percentage of missing values using this isNA and then .mean at the end. So if I run that, what you can see there is, so obviously constructive thinking, those 13 missing values represent about 5% of that, the scores on that variable, and then total worry, those 7 represent about 2. Similarly for anxiety level, so those 7 represent, well, nearly 3 for total worry and anxiety level. 3% of missing values. Okay, so what I'd like to do is, knowing that I have these missing values and knowing that effectively it can create problems in analysis by making it look like we have more groups than we need, for example, or we might have a high percentage of missing values that could affect our results. We can use to drop those missing values. In the previous video, what I did was I didn't drop those missing values. I just extracted the values that didn't have missing data and saved them as a separate object. But what we could do instead is keep our crime2 data frame object and use this drop NA method, and that will basically mean drop missing values, drop any NA values. So if I run that on this cell, and then if we use the info method on this crime2 data frame object, what you can see now is we now have a 209 non-null counts. So if you remember, the original data frame is about 235 values. I didn't ask for the head up here. Oh yes, I did. Sorry, I didn't ask for the info up here, but the original data frame has about 235 participants. So these are indexed 0 to 234. We've just dropped any row that has a missing value, I guess, on any of these variables. So if there's a missing value for any variable, it's going to drop that row, drop that participant. And what that's done is it's taken about 25 participants, 25 observations out of the data set. So we've now got a reduced data set of 209. What you'll notice though is we've got 209 observations, or 210 essentially, because it's 0 index. But the index is still showing from 0 to 234. So each observation has retained its original index number. But we can reset that. We can reset it so it just shows indices from 0 up to 209. And the way we do that is we're going to use this .reset underscore index method on this particular data frame object. And notice I've actually assigned it to an object with exactly the same name. So if I run that, that will have reset the indices. If I'd not included this first bit, if I'd not included the assignment and ran that, it would have reset the index. But then when we ran this next cell asking for the info, we would have effectively got the same information here, and it would have looked like it hasn't worked. So sometimes if you think you've run something, it hasn't worked, sometimes it's because you need to include this assignment. Okay, so if I run that now, you can see that has worked. If we compare the info for the two data frames, so we still have 209 entries. Previously, these were indexed 0 to 234. There was obviously missing numbers, missing indexes, but now it's been reset to 0 to 208. Okay, there we go. Okay, so if I call that data frame, it will condense it on the screen though, but we should be able to see there. We have 209 rows, 0 indexed to 208. It's obviously compressed it for us, but that has worked. And if our another way we can check to see if our manipulation, our operations to drop these missing values has worked is we could run the isNA.sum method again on the crime2 data frame. So if I run that now, we get an array of all zeros. So we've effectively managed to successfully drop all these missing values, all the observations that had a missing value in them. Okay, so that's just a nice little way to check. So the last thing I was going to demonstrate is that's how we're dropping rows essentially in all the stuff I've just demonstrated. So we're dropping participants, we're dropping observations, we're dropping rows from the data. But what I'm going to do now is I'm going to create a new object, crime3, and I'm going to use the original crime data frame object we imported. Effectively, I'm just making another copy of it really. And I'm going to use I'm using the apply and to numeric function again on that. So all I've done is what we did previously is like convert that original crime data frame where they're all saved as objects and string variables. I've just converted them all to floating points. And if I run isNA.mean on crime3, it gives us this percentage of missing values. So it's the same that we saw up here for the crime2 data. Gives us this percentage of missing values. I've just duplicated that again here. And if I bring up crime3.head, this will be useful for the next step. So we've got these 5 variables and we can see how the percentage of missing values for each variable. And the highest is obviously this constructive thinking with 5% missing. So what we could do is if we wanted to drop columns, drop variables that have a lot of missing data from them, then we can set a threshold percentage of missing data. And we do that using this kind of thresh argument essentially. So what I'm going to do in this next cell here is, you can see hopefully I've taken the crime3 data frame object and we're going to use drop NA again. So we're saying drop missing values, but we've passed it some extra parameters into the parentheses this time. Firstly, what we've done is I've used this thresh argument and I've set that equal to the length of crime3. So that will be the original sort of length of the data frame, 235 observations, and multiplied that by 0.97. Okay, then a comma, and then I've specified that in this case we're looking at the columns, so axis equals columns. If you see axis equals index, that refers to the rows. And then I'm just going to call the head of the data frame. So if I run this, what you can see now is constructive thinking has been dropped from the data frame and we're only left with these 4 variables. So what I've done here is I've set a threshold at 97% of the data frame length. And what this essentially means is that any variable that has more than 3% of the data missing will be dropped from the data frame. So it'll be like, and the only one that does in this case is the constructive thinking, the construct variable here that had 5% missing values. So because that exceeds this 3%, 0.97% that we multiplied by threshold, it's basically removed it, it's excluded it from the data frame. So that's just an alternative way to do things if you need to. If you want to drop variables that have missing data above a certain threshold, then this kind of thresh parameter and specify the columns is the way to do it.